In this video, we are going to be doing another law of sines problem. This whole section is related to an ambiguous case where there's this potential for two triangles. We won't be doing these types of problems. So that skips us down past those two problems down to this. So the ambiguous case will not be part of the curriculum that we're doing. So instead, what we're going to be doing is just back to our law of sines, and we're going to try to figure out missing pieces. So we got a little bit of a word problem, and we're going to figure out what's missing and find the pieces for it. So first thing is, it says a technician checking a surveyor's report is given the information shown. Calculate the missing information. So we need this length. We'll call this side A. We have the other two sides, and we're missing these two angles. All right, so first question that I would ask, is this a law of sines or a law of cosines? If I have one full fraction, because remember sines is a proportion thing. So if I have one full fraction, which is basically an angle and a side across from each other, then I'm going to be able to use law of sines. So I could start setting up my problem as sine of 43 degrees over side across from it, which is 28. And then that's going to equal, this is my other value, but I don't know the angle. So side of B, sine of B over 27. Okay, so like any proportion, we're going to cross multiply to solve. So 28 times sine of B is going to equal the other cross product, which is 27 sine of 43. All right, we're trying to isolate B. So the first thing we'll do is we'll divide the 28 over to the other side. So that would cancel this. So we're looking at sine of B would equal this fraction. Okay, that fraction is going to be some decimal. I have no idea what it is. We'll figure it out in a second. So the last piece of this is, I'm not quite ready to throw this into a calculator yet because I have to undo the sign to be able to figure out our angle. So our B value is going to be the inverse sine of this fraction, 27 sine of 43 over 28. And we'll throw that in the calculator. So when we do that, that inverse sine is going to give us an angle measurement. Okay, so let's throw that in. So we're going to make sure that our mode, make sure that we're in degrees. And then we're going to do the inverse sine, which is the blue one. So I had to go second inverse sine. And then we'll throw in the rest of the fraction. 27 times sine of 43, close the parenthesis, divided by 28. And then I got to close my original parenthesis for the whole inverse sine thing. And there's our angle. So 41.1. So angle B is 41.1 degrees. Okay, so put that on the picture, 41.1. So I can instantly figure out what angle A is because I know that my triangle is 180 degrees. So angle A is going to be 180 minus 43 minus 41.1. All right, so that is going to get me, if I throw that into a calculator, that's going to get me 95.9 degrees. All right, so 95.9. All right, so the last piece of information I have left is this side across from it. So let me go back to my original fraction that I knew. So sine of 43 over 28. And then I'm going to be setting up another one, but this time I'm going to be messing with this relationship here. So it's sine of 95.9 over side A. And then I can cross multiply. So A times sine of 43 equals 28 times sine of 95.9. And I want to isolate my A value, so I'm going to divide by sine of 43 on both sides. So then that cancels out. And I'm left with A equals whatever that turns out to be. That's going to be a length. So we'll throw that in the calculator. 28 times sine of 95.9, close the parenthesis, divided by sine of 43. So I'm going to get a 40.8 is the length. 40.8. All right, so I'll put that on the picture. Make sure the value seems okay. So 40. All right, so does everything seem to line up? Like the values make sense? We have the biggest angles across from the biggest side, and then our smallest angles across from the smallest side. But again, since those angles are pretty close together, the side values should be pretty close together, but that one should be the smallest because it's across from the smallest angle. So as long as that stuff lines up, I feel like we probably did the problem right. All right, so that was our third example of doing the law of sines to find all the missing values of a triangle.